Alright, time for another DraftPhysics.com video presentation. Lament. So, the physicist Michael guy seems to have been a bit of a fraud and a fake. And I guess some of that was smellable right from the very first conversation, where every time I brought up my conditions for the experiment, like stating that it would be a good idea just to try the simplest experiment first. Just try to make the same object, the same distance, try to just transfer the energy from one side of the lever to the other side of the lever. And he was like trying to make it, oh, it's only half, and only half the end. He already was predicting what would happen and stating it can't be done. And, so it kind of, you could smell it in the air that this was just going to be another evasion of the real experiment, evasion of the physics question that needs answering, evasion of the real proof that needs to be created for this magical, fake, and phony kinetic energy joule garbage, frankly. So let's look at a few of what exists out there already. So I would argue that they have no evidence of anything taking 4 times the fuel to go twice as fast, or 9 times the fuel to go 3 times as fast. And he made a bunch of relativity fake arguments to evade that subject, and evade having to be accountable for stating anything. I mean, we don't even know what his opinion is. Does it take 5 times the fuel, 25 times the fuel to go 5 times as fast? Is that a truth? And then I pointed out in Newton's cradle, none of this crap happens. This free momentum experiment, the Lewin experiment. You crash the little half-mass thing into the 3 times the mass object. I showed it happening. Clearly, the two things meet, so they both leave. One reflects, one goes off. The momentum is conserved. They come back together, and what do you get back? You get back exactly what you started. Okay, except in the opposite direction, ironically, right? Negative momentum. So you get back negative momentum, and you put in positive momentum. All this silly nonsense about such a thing as positive and negative energy. But clearly, it doesn't show up. So shouldn't they be able to make it happen with the simplest device possible? And then Brozo did his experiment with a spring compressed, launched the two things at the right distances, got pretty close to 2-to-1 results. Couldn't get much closer, 19 to 11, Anyway, Gosling dropped the weights on the clay, yes, the half his mass from 4 times the distance crushed the clay the same amount as the full mass, from 1 unit of distance. 2 units of force created, with half the mass, created just as much compression. So there's lots of evidence out there that this theory of theirs is rubbish, and they just won't do the experiments that'll show that. And this is the simple one, okay, that was challenged. The big challenge I made is can't somebody do this experiment? Couldn't they even just draw it and explain how it works? So his explanation is that this can't happen. That somehow I can't transfer the momentum from this object into this object. Somehow it can't be done. Yeah. I think it can. Okay. And I just think they don't want to do it. That's the simple truth. All right. So he's left this comment on the video, and it's just, I don't know why it disappeared when I put it on here. Anyway, so we'll go through this rationalization and excuse making and whatever you want to call it, garbage, frankly. So there was aspects of his experiment I didn't like from the very beginning. The big giant bearing thing, I pointed out. Gee, that's an awful big giant bearing thing. Why can't you just put a hole in the thing? You don't need a great bearing. As his preview experiment kind of demonstrates, you don't need much here. It's a tiny amount of movement in the lever that causes the whole event takes place in a tiny amount of lever movement. So in a sense, you don't need a very good bearing. It seems obvious that you don't, that you're not going to lose much through the bearing. So hell with this, whatever it is, this geary thing. This thing full of little ball bearings that's, isn't a highly sensitive machined device. Yeah, just put a hole in it. All right. Well, anyway, whatever. We'll just get to this. All this hype. He goes to the trouble that, let's make sure we agree on the conditions that we're going to do the experiment, blah, blah, blah. He goes through all that crap just to basically weasel out of the whole thing. It's just such bullshit. All right. I wanted to make a few comments about the flexibility of the lever. Well, we talked about it for 2 hours. First, I will be adding on a test with a more rigid lever. So why don't you save all this crap then until you've done that test? And you could also fix a few other things. As pointed out, obviously this lever doesn't need to be 1 meter long or whatever, meter plus. This one's even bigger than that. You could just put these two rails, really close to each other, like a few inches apart, and do the experiment. So then you'll have less likelihood to have any bending issues. So just make the lever a lot shorter, and that'll take care of some of the issues. Yeah, anyway. Alright. Early test I have done using an L-shaped aluminum bar. Okay, but my early test I have done using an L-shaped aluminum bar, whatever that is, 1/16 of an inch thick, that's L-shaped by 1/2 inch by 3 feet. The L is only 1/16 of an inch, so it has some tiny little edge on it. Which way did you use it? Aren't showing much of a difference. Any difference is indicating that, yes, do some more of that and keep going until you get a lot of a difference. I was rather surprised by this at first, learned something new, but in hindsight it makes sense. Okay, so whatever all that means. Okay, even steel has an elastic mobilis, which means it will flex. Right, but we know it's going to be a tiny amount of flexing. So this isn't, to some extent this is all a subject. As I pointed out, showing another experiment that just illustrates how their theory is nonsense is the anvil and the ball bearing. You can bounce the ball bearing 200 times, right? 200 times. So if it's hardened steel, 200 bounces, because it doesn't make any dents in the steel. It doesn't deform the steel. It doesn't, so therefore there's no deformation, and all the energy just returns back into the ball. The steel rejects it because it's a big heavy object, it's not going to move, and all the energy just goes back into the ball again, just demonstrating what a reflection looks like. Anyway, even steel has an elastic modulus, which means it will flex. Okay, but even if it has a high elastic modulus, it will flex a little bit for a short time. So again, the whole point is we want to flex a little bit for a short time. That's exactly how the energy is going to go from one side to the other side. It's going to create a vibration, and the vibration is going to push into the other side. That's the whole idea. Anyway, it's like having a spring with a higher spring constant. Okay, fine. Yes, that's what you want to do, though. That's what the Newton's cradle is doing. You want to call those springs, you want to call those steel balls springs? Well, you can go ahead and do that. I don't think it's quite the truth, but whatever. When hit, it will compress less. Okay, yeah, that's the whole idea, is to have it compress not at all, and transfer the energy to the other side. That's the whole point. But it's still going to spring back and return much of that kinetic energy, says you. So he's again still arguing that somehow you can't drop the 2 and get the 2 to pop off the other side. That you can't move the energy from one side of a lever to the other side of the lever. He's saying I can't create the oscillator, so to speak. But as I said, I'll include some trials with more rigid bar for comparison, and more detailed discussion. Well, then why are you claiming you're already done here? You're already saying you've proven it. So why all that then? Okay. You seem that you've figured out for your own satisfaction that the experiment can't be done as I described. Okay. Another thing about the bar is that if I used a sturdier bar, it's going to have more mass. Yeah, and as this experiment sort of demonstrates, maybe that's also irrelevant. I mean, I didn't consider that in in thinking about it, but the fact is that the bar's movement too can be completely consumed, and that there won't be any momentum left in the lever either. So when you hit one side, the other side will take all of the energy, and the bar will be left with nothing, because it's just going to do this. It's just going to bang. That's it. All the energy will go into the other object, so you won't have to keep moving the mass. You won't leave energy in the lever, is the idea, because it's so quick. The energy moves from one thing to the other thing quickly enough that it doesn't leave anything in the lever. Alright, extremely rigid, long, thin. So again, we don't need long. So why are we doing the long thing? Long thing is just makes it easier to see, but frankly it doesn't do the experiment any good, so long isn't what you're after. Thin, low mass objects don't exist. So we don't need very long, we need a foot. Okay, that's the truth. So a ruler will do. Preferably if it's wood, then use one with a metal edge. Okay. Yeah, get something. I mean, wood is dense, I mean, obviously, so wood has lots of disadvantages besides flexing. So if there are recommendations on what I should use for the bar, considering those trade-offs, let me know what the preference would be. So he actually showed in the original video a yardstick, a metal yardstick, it looked like to me anyway. Maybe that's his L-shaped thing, I'm not sure. But I would clearly think using that on its flat dimension wouldn't be very flexible. But doesn't really matter. Do something much shorter. That's the first thing to do, is do something shorter. Get rid of the little sponge you put on the cart, because that's just a spring. And frankly, I'd get rid of the big bearing, because you really don't need anything that dramatic. You just need something that creates some generally liberal movement. Okay, so as I suggested right from the beginning, a couple pieces of nylon or some other plastic material, a couple of layers of that with a little oil on it, should make a satisfactory bearing. I've got a 1/8 by 1/2 by 36-inch bar of aluminum. So yeah, that's going to be way too, by 1/2, 1/8 by 1/2. I don't know what that means. 1/8 by 1/2. It's either a 1/2 inch thick or 1/8 inch thick. If it's a bar, I don't know what that means. Okay, I can set horizontally. So this sounds like the same thing you're talking about at the top, the 1/16 of an inch. I don't know where he has this L-shaped stuff from, but whatever. But even along the ideal axis, it still has some flex. Well, says you. And that's already over 100 grams. Switching to steel would be about 2 times as heavier yet. Yeah, so switch to a lot shorter. Alright, next there will be more analysis in the follow-up. Yes, analysis of your spring experiments. So, your the ones I never suggested doing in the first place. I said I had no interest in seeing. All I want to see is if you can get a 2 mass to hit and a 2 mass to leave with almost all of the momentum conserved, then we can do the real experiment. Alright, showing all the steps and measurements, but if we look at the first elastic case, okay, at the 3, see, so he really thinks this wasn't a preview video. This was just going to be his, look, see, it doesn't work video. With those masses, the distance and the measurement of the inertia of the bar, blah, blah, blah. So we don't really need the calculation of the bar's inertia. What we need is to see how much energy the bar consumes in a real experiment, as well as a reasonable approximation of the angular velocity of the bar. So again, why would we use this approximation when we could just see it happen in the experiment? And the initial velocity of the cart, okay, 1 of 0.494. The predicted final velocities of cart 1 and 2 are 0.175 and 6 respectively. I got 1.3, so instead of 175 he got 0.123, so that was off by let's see, 30%. 50 out of 175, it's almost 30%, okay, and 589 relative to 637, which is again 50, but 50 out of 500, so it's not nearly as bad. That's more like 10%, okay, respectively. Fairly decent match, he says. So 30% off is a fairly decent match. For the angular momentum, which should be conserved no matter what flex is happening in the bar. Well, it's obviously not going to be conserved in the object if the bar is moving, but whatever. Just requiring that there are no external torques, blah, blah, blah. They ended up matching to within 4%. Okay, so he calls 30% 4%. Okay, whatever. I don't think I'd do that. Yeah, I don't think I'm going for that. 0.175, and the other one was 0.23. Yeah, I don't know how 0.175 and 0.23 ends up being 4%, but whatever. There is some energy loss, about 25%. So I don't know what he means by energy loss. So I guess that's kinetic energy loss. So obviously that's not very good. Okay, and so I guess he's saying the momentum was conserved within 4%. I don't know. But certainly not the significant increase in energy that DS predicted. Yeah, obviously you didn't get the energy into the other object. So the amount of energy you did get into it, it clearly increased the velocity, and the other half of the energy that you left in the other object is the reason why it's, didn't go further. So as I obviously pointed out, all you had to do is take the stuff that reflected, and if you took the reflection and you added it as a velocity to the other side, as it doubled the velocity, you would have been pretty damn close. But anyway, so he's using this crappy experiment as an argument against what I predicted. Okay, clearly this isn't the experiment I've described. This isn't the experiment I suggested doing. Blah, 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 blah. Alright, and he's claiming he's proving me wrong with this garbage. So it's just more of the same shenanigans. Instead of doing some sort of real science, they're just doing this. Let's do the experiment a way it comes out our way. We'll say we proved. Alright, and we'll just pretend doing the experiment the right way isn't possible. Okay, the other trials I have similar high quality matches with the total angular momentum. So more nonsense that says anything to do with angular momentum when clearly the carts are on a rail. It's nothing to do with angular momentum. And similar moderate energy losses. So he says 25% is a moderate loss. 25% is a moderate loss. Okay, kind of hilarious. Even the elastic cases I tried. So inelastic, I don't know what that would be exactly. The only way to use this term inelastic is to say permanent deformation cases. There's no other rational way to understand the concept of elastic and inelastic. Since the flex of the bar is doing a better job of conserving energy. Even the inelastic cases I tried. So that's, he's claiming, he's conceding the cases he did were inelastic. That they weren't rigid. They were, I don't know, I don't even know how to describe this stuff again. Super elastic is how they describe springs. So obviously inelastic isn't a spring, but whatever. Since the flex of the bar is doing a better job of conserving energy. So I don't know exactly how the flex of the bar is doing that, but whatever. clearly what it's doing, okay, is the same thing the spring is doing, which is getting in the way of the experiment. It's just something to get in the way of transferring the energy from one object to the other object. Newton's cradle doesn't need a spring. This experiment doesn't need a spring. Okay, so even with these limitations, we demonstrate, okay, so this is what he's saying. He's saying this is good enough, I've proven, blah, 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 blah. Again, with full details and additional cases later. So he's proven with coming soon bullshit, okay, that angular momentum is of central importance. So again, there's no angular momentum having anything to do with this, and angular momentum is the same as regular momentum. There's no difference. There's no difference, okay? I mean, the angular momentum is still works by the same rules, okay? The law of the lever. Okay, all right. The angular momentum is of central importance, and kinetic energy is at best conserved. I don't even know what that means. And kinetic energy is at best conserved. Just bullshit. Frankly, just bullshit. But in most cases, some is lost to other forms of energy. I don't know. So what does that even mean? You lost 25%? I don't know what your concession is. Some of the energy lost. So when you say energy, you mean kinetic energy, right? Because you never use energy to describe momentum. So 25% loss of kinetic energy. That's pretty significant loss. No free KE out as in DS's predictions. Well, we'll see exactly what your calculations indicate, frankly. If you reverse the motions. Now, maybe you'll say they're going in the same direction when one of them is completely reversing its direction. Okay, so maybe that's the dodge you're going to use, is you're going to play these silly little games about direction. All right, and regarding DS's complaint about how the flex of the bar and other realistic considerations make the test meaningless. Yes, of course it's meaningless. Meaningless to the project. The project is to conserve the momentum and transfer it from one object to the other object. You didn't come even close to doing that, so yeah, it's a complete failure. The test isn't anything like the test I'd like to do. I'd like to see done. Okay, the promised test we were going to have that we didn't get. All right, if your model isn't, so here he's going to say the model's incapable again, because he won't do the experiment the right way, therefore the physics doesn't happen. And so again, they won't ever test anything to prove the existence of kinetic energy. They're never going to show us it taking 4 times the fuel to go twice as fast, or 9 times the fuel to go 3 times as fast. They're never going to show this, that it actually happens in the real world. They'll never show us the joules of watts of energy flying out, of the collision. So I go 3 times as fast, I'm supposed to have 9 times the energy. Will they collect it somewhere and show us on a watt meter the energy's been created by the 3 times the velocity? Never. All right, will they show us a bullet doing 2,000 times the work of the recoiling gun? Ever? No, they will never show any of this. Fake physics. If your model is incapable of taking into consideration things that happen. So this is just such bullshit. We talk about it for 2 hours, pointing out these things that you have to be aware of, and then he claims, well, your model's incapable of doing any of that, blah, 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 blah. When, no, I pointed out all of this crap. I pointed out you can't have a flexible lever. I pointed out these things. And you've ignored every single thing I said. So everything I said about doing the experiment, first, just try to get the 2 to push the 2. Try to get the same mass parts to transfer their energy. Do the simple experiment first, and once you have that one, then you know you have a system that'll work, okay, that'll prove the case. And you wouldn't even have followed that advice. Okay, anyway, happen in the real world that can only make a prediction in an utterly idealized case. So again, it's not idealized. So he's calling it idealized to say, gee, you should be able to get 90% of the energy from one side to the other. That's hardly an idealization. Yeah, what a conniving person. Then your model is rather useless. So again, he's claiming proof. He's claiming he's done it. I mean, this is just disgraceful physics. He hasn't pushed on this experiment at all to see if he can get it to do something he's not gonna like. Especially since it still fails in that one idealized case you were hoping for. So he says somehow it's failed. It failed the test. You didn't give it the test, and you claim it failed the test, but you never did the test. Your theory fails. It fails in the Newton's cradle. It failed the Brozo test. Even a Brozo couldn't finagle it and cheat it. All right. Oh, man. So I'll keep that for posterity. I'll keep that pile of shit, this whole fucking pile of shit paragraph. I'll keep this. Just to show that this guy doesn't have any integrity. But as always, if you want to try the experiment yourself, so again, the whole point is, as I've been saying, somebody with a little bit of professionalism should be doing these goddamn fundamental experiments. You've had 350 years of a theory, and you have no fucking proof. You have no evidence. Your lawyer's in court just doing shenanigans, just playing with words. You won't show us a gun. You won't show us any fingerprints. You won't show us a goddamn piece of evidence. And then you claim you're going to go do it. I'm going to go prove it for you. Ha ha ha. And what do? You dismally fail to do anything close to treating it fairly. You waste a month of my time promising you're going to do the experiment I suggested, and you don't do it. Plain fact. All right. But as always, if you want to try the experiment yourself and prove me wrong, go ahead. Well, yeah, I already had that right. Thank you. Thank you for giving me the right to prove you to be a pile of shit as a human being. Okay, well, I guess I might bother doing that. Okay, if I really have to, if there's not a single person in this audience who has any kind of engineering competence and can't do a fucking simple lever experiment, okay, I guess I'll have to do that too. Shit. You people can't do anything. I mean, it's almost a test of, oh, come on. I mean, really? I have to do everything? Yeah, all right. I have to argue all these subjects. I have to make a simulation. I have to. You don't have to prove a motherfucking thing, but I do. Go ahead and prove a Newton's cradle creates your free momentum. Go ahead and show me that proof. Oh, shit. Let's see. It sounds like it'll be mid next week before my desktop is back. Apparently the pump for the CPU cooling system is failing. so it has an oil-cooled or water-cooled computer. And the new term starts for me next week, so I'll still be a bit before I get to the other parts of the video put together, and I do apologize for the delay. So whatever parts of the video that even means, I mean, really, you haven't even filmed the parts that are supposed to be. You've already claimed you will try. Okay, when somebody gives you a suggestion of something more rigid than a piece of crap, I have some hacksaw blades, so I'm thinking, yeah, that might work. It's light, rigid on the flat side, but it's almost like I want to find something that dings, something that actually vibrates, like a little piece of hard steel. Might be better even, especially if I'm going to use ball bearings or something else as a impact mechanism. But we'll see. And like I said, we already have the indication that the experiment works. The Brozo experiment already sort of proves the case. So it's not like we don't have a pretty good indication. All right. That the fact is that you can, get the energy into the objects in these different locations. But anyway, I mean, it's just, this is it's terrible. It's just terrible. Everybody turns into such a piece of shit. All right, so let's see what these, it's almost like, oh, you don't want to bother reading this garbage. Hi, Michael. It's apparent you put time and effort into the demonstration and filming, which is appreciated. Yes, but of course you start off doing exactly what I said don't do, which is don't do the experiment. Do this other thing first. Just make sure you can transfer the momentum between the two sides. Do that first. No springs, no bullshit. No, didn't do that. I like your style. Yeah, well, you would, because I certainly don't. Starting with the more flexible bar. Yeah, why would you just start with anything? Why would you even play with it at all? Why would you say flexible is good? No. Then moving to more rigid bar and show the difference, but that plan may be a little more problematic to execute in reality. So again, more crap about how, yes, it can't be done somehow. Somehow you can't make a teeter-totter. Like you say, all bars are ultimately have a flex in them in the real world, that is. And the point is a meaningful one? No. So he says carbon fiber would be a bad choice, frankly. Carbon fiber is a bunch of little fibers. It does all kinds of, theoretical flexing, I think. I don't think sound travels well through it. I guess that would be the argument. So you don't want something sound doesn't travel well through. Because in a sense, this is a speed of sound transfer. That's what the Newton's cradle is doing. It's the speed of sound that it goes from one object to the other object. If you put 6 balls in a Newton's cradle, they found that it's the speed of sound that the energy travels through the 6 balls before it gets to the last one at the end. So that this vibration moves at the speed of sound. Anyway, I used an 80 centimeter long rod in my lever test, and it was only 36 grams in weight and very rigid. Pretty expensive too. So that's, I don't know. He's talking about the steel rod going up and down. He didn't use it as a lever. So why is he talking about that? All right, anyway, I look forward to future installments. Anyway, he's not going to do he's not going to do much future installments. That's why he did this way. This is all, this is what we're going to get. 4 minutes. And then he'll do a 50-minute video analyzing the 4-minute video. Okay. Surely the moment of inertia is largely indifferent to the bendiness of the lever. So why, this weird Gosling character. So even though I've played 2 professors saying moment of inertia is just mass, he just keeps saying there's something called a moment of inertia when there isn't any such thing. Is largely indifferent to bendiness of the lever. The greater inertia of the system ensures we get no free energy. So, again, he's arguing that Brozo's experiment didn't happen. He's arguing his own Clay experiment didn't happen. And that this inertia thing somehow means that you can't, for example, throw an 8-pound bowling ball twice as fast as a 16-pound bowling ball. That's something. The moment of inertia breaks your arm and prevents you from throwing something twice as light, twice as fast. The moment of inertia shows up. The moment of inertia forces you to pour 4 times the gasoline in the car to go twice as fast. He has no evidence that this ever happens. This bullshit. Alright, let's see what Mindless says. He's got to be a little disappointed. I see what you are saying. Well, no, he concedes and just follows suit. We'll see what others recommend for the best material. Is it possible to do the test with something that minimized the collision time as well? Yeah, get rid of the stupid sponge he put on the end of his goddamn cart. Maybe you could replace the springs with a blade or something with a sharp tip. Well, I don't know about that. I see other videos that do something like this. Well, where do you see them? Let's see those videos, please. Could you please link me to the videos that are doing anything decent in physics, any decent physics experiments? Of course, those would require you to make sure they are aligned exactly forward, which would be another complication. I don't know what that means. Nonetheless, I think it would be worth trying. Maybe it could minimize energy loss, although if it's not aligned properly, I could see it increasing energy loss. I don't know what he means by that, all that crap. But I don't know what sharp tip. Sharp doesn't sound like a great idea, frankly. Yeah, I don't think you want anything too sharp. But anyway, you just want nice contact, a nice hard contact point. Contact point, hit point. Contact point, hit point. Nice, firm contact. Nice, good. Like if it was electricity, you want a nice, good, solid contact so the watts can go in there. Alright, so anyway, I don't think there's any other comments on the video. So disappointing. And such. God damn it. Alright, wait, so we'll see. Yeah, we'll see. I really don't want to do experiments, but if, it's there's a point where I guess you can't, I have offered people money, can't, but it's just this audience is too shitty. Okay, apparently the audience is just shitty. There's not anybody in it who has any kind of interest in science and any kind of mechanical skills. Those two things. No, nobody. A workshop, kind of thing. Nope, no one qualifies, sadly. All right, so I'll see what I don't know. I don't know how to react. Just dragging this all out, and again him preaching this shit. Oh, I proved it. Just when the experiment isn't anything close to what the criteria that was supposed to be agreed upon. Is this the agreed upon criteria? I don't think it is. So, I mean, he's violating his whole purpose of doing his stupid video was to sit there and say, well, look, let's not have any disagreements about how the experiment should be conducted. And then he just goes ahead and ignores every single thing I said were kind of, non-starters. I mean, this is what you have to do. If you can't get this done, there's no point in doing the experiment. I mean, as I pointed it out, and I directly said, I mean, if you can't get the 2 mass to create the 2 mass, there's no point. What chance do you have to get the energy into the 1 mass if you can't get it into the thing that's identical? If you can't get to duplicate the Newton's cradle, there's no point in going any further. But I really think you can. I really think you can engineer the experiment correctly and accomplish that task. All right. Smaller bearing, smaller lever, blah blah blah. Bring these 2 things closer together. All right. Anyway, till the next time and such. Shit.